Both of these questions can be answered by using a method called completing the square, which is an algebraic technique that I can use to take a trinomial like we have here, and it even could be a binomial, and turn it into a difference of, or sum of perfect squares. So the rules for completing the square, first of all, the leading coefficient has to be a positive 1. So in this particular case, the leading coefficient is currently a 7, so I'd have to factor that 7 out. Down here, the leading coefficient is a negative 7, so I'd have to factor the negative 7 out, and I'll show you how that works. Now when we're looking at this and we're talking about the leading coefficient, we mean whatever the constant is right here in front of the highest power. So x squared is the highest power, so 7 is the leading coefficient. Down here, x squared is the highest power, so negative 7 is the leading coefficient. Now after you factor out anything that's in front of the leading coefficient, that it's not positive 1, the second step is to take half of the linear term and square it. And completing the square works two ways. It can work with an expression where there's no equal sign involved, and if I'm working with an equal sign, then I have to make sure whatever I do to one side I do to the other. And if I'm working with an expression, I need to make sure if I add 7, I subtract 7, and I keep that zero-sum property in place. After you square it, you either have to add or subtract to balance the expression, and then I have a sum or difference of perfect squares. So let's go ahead and look at, this is actually the harder one, so let's go ahead and look at this one. Negative 7x squared minus 42x minus 57. So like I said, the first step we're going to do is go ahead and factor out a negative 7. If I factor out a negative 7, I'm left with x squared here plus, now if I factor negative 7 away from a negative 42x, I'm left with 6x, and then I'm leaving this negative 57 over here because that's going to be my sum or difference of perfect squares. So from here I have the negative 7, and then like I said, you take half of your linear term. 6 is your linear term because x to the first would produce a graph of a straight line. So 6 is my linear term, half of 6 is 3, and 3 squared is 9. So that plus 9 goes right here. And that x plus 3 goes right here. So again, this is half your linear term. Now what ended up happening here though is I didn't really add 9 because I have this negative 7 out front. So I actually subtracted 63. So to compensate for subtracting 63, I need to add 63 to keep that balance of this equation. Over here, I have 63 minus 57, which is going to be a positive 6. Now when I rewrite this, I have 6 minus 7, quantity x plus 3, quantity squared. So this is completing the square. And you can check this, so let's go ahead and look at checking this. You can check this by re-expanding it, and when you re-expand it, you should get exactly the original expression you started with. So let's go ahead and distribute through that negative 7. And then combining our like terms again, 42x. Negative 63 plus 6 is a negative 57. So this does check because I come right back up and get what I started with up here. Now, this goes underneath your radical from your question up above. So you're left with 6 minus 7, x plus 3 quantity squared. And then to get started here, what you can do is identify your a. Your a would equal root 6, because remember it's a squared minus u squared. And here your u is going to be root 7 x plus 3. And the recommendation for the form of a squared minus u squared is to let u equal a sine theta, and you should be on your way. U in this case would be root 7 x plus 3 equals a, which is root 6 sine theta. And then you can go ahead and solve for x, find your dx, substitute in, and you have a nice little trig sub. So hopefully that helps get started with that second problem. And again, the second one was more complicated. It's going to be that same approach for this problem up here. Now I realize that these only want you to go to the u substitution part, so they only want you to solve for x. Okay, but it would be good practice to finish solving these all the way through. Hope this helps. Bye-bye. Have a good weekend.